Alright, so I'm going to be covering Chapter 4, problem number 57. Problem goes, dancers experience large forces associated with the jumps they make. For example, when a dancer lands after a vertical jump, the force exerted on the head by the neck must exceed the head's weight and by enough to cause the head to slow down and come to rest. The head is about 9.4% of a typical person's mass. Video analysis of the 65 kilogram dancer landing after a vertical jump shows that her head decelerates from 4.0 meters seconds per second to rest in a time of 0.20 seconds. The question is, what is the magnitude of the average force that her neck exerts on her head during the landing? So first let's draw a free body diagram. So let's have this point right here just be her head. Let's draw the forces that are acting on it. So the head, so she's landing. So we have the weight of her head, the force of gravity. But then we have the force of her neck pushing up on her head as she comes to rest. Let's call that N because it's kind of like a normal force because her head's coming in contact with her neck and her neck is resisting it. Ask what is the magnitude of the average force that her neck exerts on her head during the landing? So we're trying to solve for N here. Solve that, use that by using Newton's second law. So the sum of the forces is equal to, let's have up be positive, down be negative. So we'll have N minus W equals MA. And then if we were to solve for N, be N equals MA plus W. And then we have an unknown here. We have acceleration, but luckily we can solve acceleration based on the information they gave us. It said that the initial velocity is 4.0 meters per second. So we'll just do acceleration equals v final minus v initial all over t. V final is 0. So acceleration here is just negative vi over t. And that'll give us the acceleration that we need. So then if we were to plug that into this equation, so then we were to have N equals M times negative vi over t time plus the weight, which is just the mass of the dancer's head times acceleration due to gravity. So if we were to plug all these values in, since that's negative, let's actually have, no, okay, yeah, just keep that. Okay, so then after plugging all those values in, so we have acceleration. Okay. So we have the equation that we need in order to solve for this. Alright, so if we were to plug in our values, so M is the mass of her head, which is 9.4% of a typical person's mass. So mass would be M equals 0.094 times 65 kilograms. So we'll plug this in for the mass values here. And G is 9.81 meters per second squared. And then VI over T accelerates from 4.0 meters seconds to rest. So velocity is